Hey everyone, today we're gonna be doing a lead code question which is to find minimum number of moves to make everyone seated. So they are saying like they are given some seat array and the student array in a room, and we are given the like both of will be size of n. They're saying like in every seat array I represent the position of a seat which is available or the vacant seat. Similarly for the student array, the jth student uh, tells like a student is standing at which particular position. They are saying you can perform n number of steps. You can say you can perform n number of steps. Either you can increase position by one, or you can decrease the position of one for a student to make them seated in a particular position. They are saying like return as the minimum number of moves required to place all the student to a particular seat. They are saying no two student will be sitting at a particular same seat. They're saying like there will be multiple seat, multiple student standing in the same position at the beginning. We need to like place all of them like at like you can see in a constant. They are saying there is equal number of seats and equal number of students given to us, which is ranging from 1 to 100. We need to place all the students to some seats, and we need to take minimum steps to place all of them. So they are given some, for example, the seats and student array. So let me draw and show you with some example of code, like how we can take, we can like make this work. So I have two array. I have given some seats array. I have seats array which represent 1, 3, 1 and 5. So I have 3, 1 and 5 as a seats array. So these are the available seats or the vacant seats. Similarly, I have some students array which say at particular like the students like three given students are standing at which particular position at a moment. So they are saying I have this seats array, I have this seats array, I have the students array. I need to place all of these students to some seats in a minimum number of pace. So what I can say, okay, let me make the seats, and if I say for now I have 7 seats, or you can say 7 students. So I'll create some array of a size, you can say 8 I'll take. So I'll create some array with this size of 8, 0, 1, 2, 3, 4. Let me take from 1 itself, because we are just marking the element for now. So I'll say okay, 1, 2, 3, 4, 5, 6, 7 and 8. I have this particular positions both for seats and both for students. So these are some positions. I'll say okay, with orange I will be representing students. Okay, this represent students, and similarly with yellow I will be giving the this is available seats. Or let me draw some other example, the like symbol. So I'll take some seat like this. uh, Let me do like this. So I have some seat like this, I have the seats. uh, Let me take something else so that can be visually appealing. So what I can say, okay, let me take this circle as symbol. So I have the seats available. Now this represent available seats. I'll say vacant seats. I have this vacant seats. Okay. So for now, for this example, I have vacant seat at third, fifth, and first position. So I'll say mark. I'll say okay, this particular seats is vacant for now. Sorry. Similarly for this particular seat, this seats is vacant for now, and similarly this 5 is vacant for now. Now they are saying I need to place this students in a seat in a minimum number of ways. So for now, this student is standing at which position? I have one student standing at second position. I have one student standing at seventh position. I have one student standing at fourth position. So I have this student, I have one more student. Okay, I have total 3 students, I have total 3 seats. So they're asking me what is the minimum number of step, like minimum number of moves a student required to get placed. So every, you can say every student have 3 choices for this particular question. So I can place this over here, over here, over here. Similarly, I can place this over here, over here, over here. For this also here, here, here. So what I can say, like if I be greedy over here, what I can say, I can place the student to the nearest seat. So I'll say, okay, place over here or either here. Similarly for this, place over here or here. Similarly, this can go for here. So let me place this one first. I can place this one over here. I'll say, okay, you can here, you can go here. Okay, sorry. So I have this one. I can mark it over here. I can mark this over here. So if you see what I have done, I have placed this student over here in how many steps? 2 steps. Similarly, I have done this in one step. For this, I have how many steps? One step. So in total, I have taken how many steps? In total, I have taken total of 4 steps. One for this, one for this, and two for this. So I have been greedy over here. So if I can do this with greedy, what about like doing the sorting? Like if I do this array as a sorted one, I will be getting the first vacant and the first student to be placed with the initial, you can say initial index, or you can say starting index. So what I can do, I can take this particular array, I can sort this one. Let me take the complete. Okay, I'll sort this one as per the approach. So what I can do, I can sort this array. If I do the sorting for this, if I sort this array, it will become 1, 3, and 5, and this will become 2, 4, and 7. Now, if you look over here carefully, so what I am saying, I have some student, uh, this. So this particular need to be seated over here. This need to be set over here. You can say this will take how many steps. So if I say minimum, it will take this amount of step to be seated. So if I say for this particular seat available, this student take 1 step to get seated by decrementing by size 1. Similarly, the student 2 placed currently at 4th position need to get the third seat by decrementing 1 position. Similarly, the student standing at 7th position can get the seat by decrementing its 2. You can say it can come back 2 position. So what I can say, I can sort this array and I can take the absolute difference between the seats, the vacant seats, and the student need to be placed. Sorry. So if I do the sorting, I have the seat in the increasing order. I have the student in the increasing order. I can take the first available student. I can take the first available seats. I can take the absolute difference and I can place them. So for this, I have the absolute difference as 1. For this also 1. For this I have 2. So if you say 2 minus 1, 1, 4 minus 3, 1, 5 minus 2 is 2. 7 minus 5 is 2. So in total how much I have taken? 4 steps. So I have taken like 4 steps. It is a minimum step. So approach 1 we got, like if I say I have got one approach. So you can say in approach 1, this is approach 1, we have taken like log n time complexity and log n, because we have done this sorting. We have done this sorting in increasing order. So it is taken n log n as a time complexity. But we need to still optimize further. Like see, it will work because the, you can say constant over here, it is given like sorry. So we have the constant over here. They are saying it can go from 1 to 100. At max it can go 100. So it's better to do this one as well. But I have one more optimized approach. What I can do, I can make use of a count sort. So what we can do, we can use count sort over here. So count sort is similar thing, but we are maintaining some frequency or the counting part in this particular sorting algorithm. So either we can take some array or we can make some hash map. Okay, we have some frequency array or we have some hash map used in the count sort. What I can do, I can take this example again. So let me take this one. I have this example. Let me also create like this I have. So what I'm saying, if I can like be a greedy over here, and in a question they are saying the size can go from 1 to 100, the n can go from 1 to 100. So let's create some frequency array from 1 to 100. So I can have my vacant seats available from, like, every seats are remaining 0. I can have 101 seats because I will be considering from 1 to 100. So ignoring 0, I can have total 101 element. Similarly, I have remaining students. I can say I need to be place some student. I can say remainings. Okay. I have some remaining students. Remaining. I have some remaining student also with frequencies, like they will be standing at some position. So what I'm trying to say, I can create some frequency array. So let me take, like, either I can go to 101 step, or either I can take the maximum of both of them. So I can take maximum from this or maximum from this, like maximum of both of them. So I can have at max this many seats available or student available to be seated. So to be having greedy, I can create this both array. So I have vacant array. I have this vacant array. Also I have what? Remaining array. Okay. I will be taking both size of a 7. Oh, let's take 8 for now. So I have this size of 8 over here, 0, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, I have this one. I need to be mark this as a for both of them. So simply I'll duplicate. I have remaining students, I have vacant seats. Now what I can do, for this, like, I have available seat at 3, 1 and 5. So what I can do, I can mark this one. So I have third position as available. Let me take some another color. Okay, third third position I have available. First also I have available and fifth also available. So remainings are 0, like these seats are occupied. Now, similarly, the remaining students. So I can say this remaining student, this a student is standing at 7 position, or let me say this is a position array. Okay, this is some positions given for the student. So I have some student position. So let me mark it now. So I have one student standing at second position, one is standing at seventh position, and one is standing at fourth position. Rest positions are occupied already. Now I need to get the first element. Like, see, after doing the sorting over here, we are taking the first remaining, you can say first available seat and first available student to be placed. Similarly, by creating the frequency of array of 100 size, I can reduce my this to n plus k. You can say n plus, you can say n into 100 times, because at max we can loop till 100, but 100 is a constant, so at max you can say time complexity will go to order of the n, because this is fixed of 100. What I can say, uh, I will be like getting the first available vacant seat and first available student. So for now, for this particular case, I have this particular student available, I have this student available, I have this available, and I have this available. So for this, I have took how many count? For this, I have one difference. For this also one. For this, I do. See, what I'm saying, like, I need to find the first available index, which is not. You can say first available vacant. First available vacant index, first available student index. So difference of both of them will give me how many steps this need to be moved, like this student need to move to get placed. Similarly, next available vacant seat, next available student, next available vacant seat, next available student. So we are doing somewhat same over here, like we have done whatever here. We need to do same over here, but in a frequency array. So we will be taking extra. See, here what we have done, we have took the time complexity to n plus k, where k is 100, and you can say we have took the space complexity of 100 size, or you can say k is something. So it is a constant of 1. So we have reduced our time complexity to order of n from n log n. However, both of them will work fine because our like input size is 1 to 100, so it is very less. So let me do let me code this one so I can explain easily like what I'm trying to say. So I have some so let me make like I will be having some minimum moves to be placed. So it will be initial 0. Now I will be having some, you can say, vacant index. I have vacant index starting from 0, and I will be having my student index, available position index something. So I will be having some position index. Okay, or let me make it pi and vi. So these are the vacant index and vacant for like vacant index for vacant seat and like position index for position seat. I will be having my position position and vacant seat. So I will be having both as marked as 101, position and vacant. Okay, I will be marking this as a vacant seat, and this is a position of a particular student which is available currently. So now what I need to do, I need to fill up this one. So I'll say okay, seat available in seats, and mark this in a vacant, like this particular seat is empty for now. So I'll say okay, mark this one, this seat as a vacant. I'll increase its frequency. Similarly, I will be having my what, student, for students, student in students. So this is student. I will be marking my position, the empty position, the first, the person standing at some position. So I'll say position of a student. So how many position, how many students are standing at this particular position? I will increasing both of its count. Now I need to place the student, you can say. So I will be having my remaining student. So I'll say okay, student remains. How many student remains? I'll say length of either of seats or student. So I need to place these many students. So at last I will be like returning my what, minimum moves I have took to make them place. Now our logic goes over here. So I will be looping this till my remaining of element, you can say remaining student goes to 0. Till it is greater than 0, I will be like continuing my logic. Every time I am getting my student, or let me say, so whatever I'm doing, like we will be finding the first available vacant seat. So I'll say okay, till vacant seat at vi. So vacant seat at particular index is equals to 0, means it is occupied. You can move one step ahead because we are checking for first available vacant seat. Similarly, we are checking for first available position, where student is standing at. So I'll say okay, this is what, p of I. I'll say we are checking for the first available position. So if it is once this loop get breaks, it is equals to 1. It is like we need this particular position. So I'll say okay, I'll say position of I plus equals to 1. Here also plus equals to 1. So we are like getting the first available vacant seat, and the first student need to be placed. Now here what we need to do, now we have one vacant seat available and one position of a student available to be placed. So what I'm saying, like now minimum moves we required will be the absolute difference. So I'll say okay, absolute difference between what, the vi minus si, sorry, pi. So like anything can go from first, like the first available position or the first vacant seat. Now what I need to do, I will be like doing, like see, after placing one element or one student, my remaining student will get decrement by 1. Similarly, the available vacant seats. So our vacant seat, for that particular, you can say, index. So I'll say okay, for vi, I will be like decrementing its count because I have took one vacant seat from here. Similarly, for available student, so I'll say position of particular, you can say, position index will be decremented by one position. And at last I will be like doing the count here, like how many vacant seats we have took so far, like what is the absolute difference between the first available seats and first available student. So let me compile this code now. So let's see whether it is running fine or not. So if you can see, we have compiled this code and it's running fine. And yeah, we have done this in an order of n time complexity using some extra space, which is also constant, like it is going from 1 to 100. So you can say, yeah, we has optimized this further. So yeah, that's all for today. This is what I'm trying to say. Yeah, that's all for today. Thanks for watching.